Hey everyone, Dr. Crayhay here. So here's my second lecture on Chapter 1. So I'd like to just briefly discuss features of good scientific theories. So this is something that we'll really dig pretty deeply into over the course of the semester, but there are a few things that we should discuss up front so that you can keep your eyes open for it. So your textbook discusses these 4 features of good scientific theories, and I just wanted to give a brief overview of some of these. And so the first is that a good scientific theory is supported by data. So in the last lecture we discussed data briefly. Remember, it can take various forms. It could be in the form of numbers, it can be words taken from interviews from people, it can be observational recordings. You put people or animals in certain situations and see how they behave. Whatever the data may be, good scientific theories are supported by data. Good scientific theories are falsifiable. So one thing in science that we strive for is to always try to disprove things. So we have this tendency, just human beings in general, to search for things that agree with us. So whenever you go to Google to search for something, say you want to know if the easy accessibility of guns causes school shootings. So what are you going to Google? I asked a class of mine, I had about 100 students in class that day, and they all told me, they said that they would Google the role of guns in school shootings. And I asked them what kinds of articles come up. And of course it is all articles discussing the roles of easy accessibility of guns in school shootings. So we tend to look for things that agree with us, and it's really easy to find. So if you want to support any argument, go to Google. So pause the video, go try it now if you don't believe me. You can, the way that you Google, you can find things to support just about anything that you say. So instead, in science, we want to try to falsify things. So we want to try to disprove. And if we can't disprove, then we accept it as truth for the time being. So let's skip down to that last one. They don't prove anything. So yeah, we look to falsify something, and we are unable to do so. We do it again, we're unable to do so. Do it again, unable to do so. So maybe we accept the theory of gravity. The great thing about science is that it's always open to being wrong. So if something came along and it showed, hey, you know what, gravity, not working anymore. Science is prepared for that. We'll just keep investigating, we'll go back to that theory data cycle, we'll figure out what's going on. So it's not that we do one study, bam, we're done. This is it. This is exactly how things are for the rest of time. That's not how science works. We don't really prove anything. We only provide evidence for. So as you're writing up your term papers, as you're turning in your assignments, I'm going to encourage you strongly to not use the word prove. That really gives a sense that you've shut the door on the topic, and that's kind of contrary to what science is doing. With science, we want to keep that door open. We have our theories supported by evidence, but that doesn't mean that we're never willing to consider the alternative. So we don't prove anything, we just provide evidence for. So the one that I've skipped here, good scientific theories have parsimony. So this is the idea that the simplest explanation wins. So if you have 2 competing theories, they have about the same amount of evidence for each. The simplest solution is the best. This is also called Occam's razor, so you may have heard that somewhere else. It's just the idea, all other things being equal, the simplest solution is the best. So we really, we want things to be simple, we want things to be understandable. If we have to, if we have a particular scientific theory and it causes us to put on hold all of our knowledge of, say, something like gravity, we're not going to accept that scientific theory, right? We're going to continue to investigate. So 2 things being equal, the most, the theory with the most parsimony is best. So these are, again, just really briefly, 4 features of good scientific theories. They need to be supported by data. They should be falsifiable. They should have parsimony. And again, we don't prove anything. We just provide evidence for.